Hello, my name is Bruno Babé. I work on the C++ group and Delphi in the RAD Studio team here at Embarcadero. I worked at CodeGear and Borland before. I have actually been with Borland since 1989 and have been involved with various versions of the C++ and Delphi products. Today I'd like to talk to you about a new feature in XE2, C++ Audits. And before I get into C++ Audits, I should probably cover something for which I don't have a slide, but I'll just cover it on the first slide, which is why is C++ late to the audits game, the audits feature? Delphi has had audits and metrics for years and years now, for many versions. And over time, we've looked at adding this feature to C++, but the main reason is we couldn't do it is because the current C++ compiler, which actually goes back to the days of Turbo C, is not structured in a way that allowed us to do this kind of thing, which is like, auditing code. The main reason is because typically most of us think of a compiler as, okay, you feed the compiler a translation unit, some source files, maybe those files have include files and so forth. The compiler, crunches through that source file and builds an AST, an in-memory representation of the source code. And that's typically the way most compilers work. And then from there, okay, something else comes and reads the AST. That something could be an audits engine, or it could be, it could be actually code generation. It could be like a backend that's going to generate object files or DCU files. The C++ compiler, as it is right now, as we know it, which is BCC32 or Comp32X, does not actually work that way. Due to, historical reasons and memory constraints, and for performance and speed reasons, the way the compiler works is actually it processes a little block at a time. Like, if you have a function and then the function does an if block, the compiler just goes to the if block. It builds enough of an AST for just that block, and as soon as it's done, it flushes that block out. In the case of the C++ compiler, it means it sends it to the backend, and the backend writes the object file, or writes enough information to generate an object file later. And then the compiler tosses away that AST that it just built. So because of this, the C++ compiler was just never suited for auditing. And we basically had to wait until a new effort of using a new front end that approaches things differently, that actually builds a whole AST in memory before we could consider doing audits. So that's the main reason why Delphi has had audits for a really long time and C++ hasn't. I'll touch more on that a little bit later as we get more into the presentation. So, okay, so the first thing I'd like to mention is there are 40 plus C or C++ audits in C Builder XE2. I will show in the IDE when we get to the demo. You'll get to see them. I won't show all of the audits, of course. I'll just cover a few, but it kind of give you a sense for the flavor for what kind of things audits do. The other thing that I will touch base on is the fact that this is really early work. This is the first release. It's not really fully integrated in the IDE yet. For example, the audits engine, even though it's running in the IDE, it's really more like a command line tool. So it doesn't have access to the virtual file system of the IDE. What that means is you need to save all your editor buffers before you run the audits, because otherwise it's actually accessing the files directly from disk, so it will not see any pending changes that you have in the IDE. That's a big change, and that's something we want to remedy, because Everything else, pretty much in the IDE in C++, works directly off the VFS, like the class browser or code completion or even the compiler. So meaning actually you can do all of these things without even saving any files. You can create a new project, never save it to file, and browse it or build it or run it. But the Audit subsystem does not have this level of integration yet. So no access to the virtual file system. It's also Windows only for now, even though in XE2 C++ supports OS X, Mac development. We just didn't have the time to tune the subsystem for OS X. That's something that's coming. A lot of the audits that are included are actually based on, what should I say, standards. There are many organizations out there that have recommendations on how to write code in ways that avoid defects. You may have heard of GSF and various other organizations that have those coding standards. Several of the audits that are included in XE2 for C++ are based on the common weakness enumeration, CWE. And the last thing, different front end, I mentioned that earlier when I was talking about why C++ is late to the game. It is a different front end, and that matters in the sense that you might have code that will compile in the IDE, but that doesn't audit very well. Or you might have code that audits very well, but somehow doesn't compile in the IDE. That's again because of the fact that there are two front ends currently. We are bridging the gap between these two front ends, and I'll touch base a little bit as we go through the demo on certain things that will be different between one and the other. So, okay, so to actually get into audits, get to see it, it's best that we just go to a, well, actually, it's called demo, but it's not really a demo because I'm going to start from scratch. I don't have anything prepared. So what I'll do here, I will switch to this machine. I will launch C++ Builder 2, C++ Builder XE2 I meant. And I will just kind of, okay, so I'm starting here with brand new, no project. I am just going to go and create a console project. The idea here, or maybe I'll just create a VCL form application. As I mentioned, the Audit subsystem does not have access to the virtual file system, so I need to save all the files. So I will do that here, save all. Save this, save the project. And then simplest way to launch C++ Audits is to actually view and then C++ Audits, which brings up this view at the bottom here. Keep in mind that that can be confusing. There's also another audit tabs and a metrics tab. These are for Delphi, and the C++ audit one is for C++. We are working towards having one unified view so that this is not so complicated and confusing. So, and to launch audits, you just have to click on the little go button here, and this UI comes up. This is the UI where you select which audits you want to run. There's a little preview at the bottom here that gives you a list of all the audits when none is selected. If you actually go and select an audit, then it will give you a little more detail about that audit. For example, this. Okay, so core.divide 0 just basically checks for division by 0. There are other audits also. And each one of them has a little description. So I'll grab something else like naming convention. This audit is just make sure that your code conforms to some naming guidelines. It's not something you would use very often because it's very hard to find a naming convention that works across all of your code, because in C++ very often we're mixing libraries. We're using a little bit of Boost, a little bit of VCL, a little bit of, all kinds of libraries, and all these have their own little naming guidelines. And so you'll see that naming conventions was not turned on by default. We turned off the audits that we deemed would result in too many false positives. I mean, things that you don't really want to hear about. But let's say if you want to know whether your code compares floating point numbers, then this would be one audit that you would turn on. So for now, what I'm just going to do, I'm going to say select all, which turns on all of the audits, and I am going to run start. You just click the start button, and you see here it's running the audits on two files pending, and found a few things in our own header, actually. So there were 4 items that were found. There's a cast to a non-structure type to structure type. And you can see that here. It's a little... our audits is unhappy with the fact that we're taking data from a Unicode string and casting it to a pointer, to a structure. And actually, it's not just our audits that doesn't like that. It turns out that CodeGuard also doesn't like it, which is why in the header there's this if not defined CodeGuard. And so anyway, I just wanted to run it. So not much is found, of course, when you're just doing it on a simple VCL application. There's actually more things that would have been found, but the audit subsystem suppresses all reporting of all messages from system headers. And the fact that uString and dstring here are showing through is actually a bug in the system. It shouldn't be showing these either. So there was not much here, but I just wanted to give you a feel of how you run it. So now, to actually see audits themselves, I'm going to use something a little simpler. I'm going to create a plain console application, a console app here, and I'll say nothing. I will save it. And maybe I'll put something a little useful here. I'll call printf hello, just so we have something a little useful. And just to make sure that everything is okay, I'm just going to run this little app. Here's my app. Hello is here. Let me carry on. Okay. So now I'm going to run audits on it. That was fast. Zero of checks or audits. We use that term, the term check or the term audit interchangeably. We might actually want to clean that up so that we were consistent. But okay, so 0 audits were found in my little console application. And now I will look at some sample audits. So what I did is I created a separate unit here that I call test unit. And I'm going to copy code from this little file that I've created here into file 2.c pp, which is my console app that I just created. As I copy code, I'll talk about the code and then run the audit so that you can see what it's about. So the first thing that we'll look is something that's actually used by the RTL. So let's say I have some functions that cannot take null as parameters. Okay, things like string copy and memcopy and memmove and things like that. So the way you tell the audits engine that this parameter cannot be null is as it's shown here. You use the underbar attribute underbar and then say non-null and give it the index of the parameter. In this case, this is the one and only parameter, so this parameter cannot be null. Okay, so in the typical case, that's not the way it's going to happen. In the typical case, this would be in an RTL header, in a .h file somewhere, standard IO or standard lib.h or something like that. And this would be somewhere else. This would be in the RTL. And then all your code is calling it. So I have a function here called takes non-null. and I'm calling it, but I made a little mistake and I'm calling it incorrectly. Well, I'm not aware of that, so I'm just going to run my audits. And you see there's one thing that's flagged here, and it says argument with non-null attribute passed null. And it gives me the line number. I can double click and it takes me there. So this is one of the audits. It's just it catches cases where you're calling functions that don't expect null with the null parameter. Now, for this to be really useful, the attribute would have to be applied to functions that don't accept null parameters. We are in the process of doing that, of applying the attribute non-null attribute to RTL functions. Not all the functions that don't accept non-null parameters have the attribute yet, but it's something that you can apply to your code also. So this is one audit. And let me go back to test unit. I'm going to grab another one, which is probably a little more interesting because it doesn't require any particular attribute division by 0. So I have a little function here called calculate. Takes an x and a y and then does a simple calculation with it. Again, as far as I'm concerned, this looks good, but the audits engine catches and says, no, because based on the path analysis, you are evaluating when x is non-zero, you'll return x. The else of that ternary operator is, x is 0, and then you're taking y and dividing it by x. So obviously that's a division by 0. I'm using very, very simple examples here because, well, it's much easier to illustrate the audits that way. And also, yes, it's much easier for the audit to fire that way. It's the audits don't always catch all cases because, well, because of various reasons that we don't need to dive into, but it can only analyze based on the data that it has, and it doesn't do it doesn't check values passed between procedures, for example. All the analysis is done within one procedure, so it might not take into account what another function that you called would return, what values are passed between them. But the basic idea is it's a tool like every other tool. It might help you find certain defects and or might not. It's totally based on static analysis. So that's division by 0. I'm going to go back to the other file and grab. Okay. This is, maybe I will paste it into my little here. And those examples are so simple that you probably already spotted the problem. I have a function that takes a pointer to a struct s and accesses the member val of s. But there's a little if here, which is what the audits will use and to determine that pointer is nil at the point that you're accessing pointer. Again, very, very simple example, but so here's the error message. Accessing field var is dereferencing a null object. So okay. So again, nothing very fancy in the sample. I mean, it gets really interesting when there are multiple paths. Imagine if inc is not as a simple function as it is here, but there's all kinds of blocks and all kinds of tests been done, and a very subtle bug might creep in, and the analysis engine might be able to detect that and say, ah, this is what happens. And actually, the engine that we're using provides way more information. It provides actual very detailed information about which paths were in effect when the actual audit or check was triggered. That information is not yet surfaced through the UI right now. Right now, we just send the one message that we get back, the final message. But ultimately, I'd like to find a way to expose the path information that's surfaced by the engine. I will take another one. This is a case where so I'll replace the code that I'd put into my console app here with this function, getString or getStir, returns a char star. But, well, let's run, and then you'll see what will happen. So, the problem is that return of message, which is here, is actually returning the address of a local variable. So, because message is an array, a character array on the stack. So, if message was actually like this, instead of a character array, then I will rerun again. There wouldn't be any audit fires because it's just a pointer to const data, which is not on the stack, which is allocated in the data segment. But the earlier version that I had was like this, which is where the problem comes from, because we're returning the address of a variable that's on the stack. So so that's the problem case here. Okay, let me go and find another one. So in this case, I'll copy it back to the little console driver that I have here. Save that and run. Okay, array subscript is undefined. Because what happened is the function subscript here received a parameter I. That presumably is the I that probably we should have used when we access data, but a mistake happened and an integer I2 was declared but never initialized, and then that integer was used to subscript into the array. So the logic says, so I'm going to run it again, that we are subscripting into an array that's with an index that's totally undefined. That's whose value is undefined. So, but if I were to change the value of I2 to, let's say, 2, then in this case it changes into something different, which is the garbage values returned to the caller, because yes, now the index has been initialized, so I2 is no longer the problem, but data was not initialized, so whatever we're returning to data is totally undefined. So this is the case where basically, I mean, it's two different audits there. When we fix the I2, we assign I2 a value, now and a different audit fired, which is garbage return value. So so that's just another example of another audit that now we're back to the original array subscript thing. Let's see. Do I have anything else? Oh yeah, typical out of bounds. So I'm going to copy this code. Just paste it here. So let's run this. I didn't save. As I mentioned, each time when I've pasted here, I usually have hit Control S. But as I mentioned, that the Audits engine does not have access to the virtual file system. So just before running, it will check whether there are any unsaved buffers. If there are unsaved buffers, it will prompt you, and in which case I'll just say, yes, I'll save everything. And then here I see another one, which is an out-of-bound access, because I will run from 0 to 3, but my array has only 3 elements in it, which means I should only be running from 0 to 2. So I have an out-of-bounds access here. So anyway, I hope those little snippets of code, which granted are very, very, very simple and don't really represent the complexity of the kind of code that you deal with on a day-to-day basis. But I hope that actually the idea of what are the kinds of audits, what kind of things that they catch, that you have an idea what it is that running audits on your code is likely to find. Those are not the only things. I mean, I've looked at mostly audits that focus on what I will call C code, just kind of pointers and dereferencing null and stack address escape and uninitialized value. But there are things also that are more C++ C. So let me give you an example. I don't have a sample of that in the other unit I've been copying from. But I can create something. Let's say I have a class test and I have a private field. It's an integer I. And then I have a method that returns I. So like this. Okay. So now if I run this, you'll see what happens. So, the method getI can be made const, and that's true because getI is simply returning I. It's not modifying test, and so therefore I could mark getI as const. That's C++ const correctness. So, but let's say actually getI returns a reference to I instead of a copy of I. So now I no longer get that audit that getI could be made const because getI is returning a reference to an integer, not. But let's say it returned a const reference to an integer as opposed to a reference. Run the audit again. Now we're back to, yes, getI could be marked const because it's returning a const reference to an int, and therefore it can return I. So the way it's very simple things. I mean, so basically what the audit is saying is you should really put that const keyword here, and then voila. So and this was actually an interesting one for me because I was interested in finding out, like, are we const correct in some of the very classes that we ship, and so the person who was working on this audit had checked it in, and I went ahead and ran it on some of our code. As usual, there were some false positives. We had to kind of narrow down certain cases, like the case that I just showed there. So, okay, so you return an int, but then if you return a reference, then the rules change, and then if you go back to const reference, the rules change again. But the audit actually did catch several cases in our own code where we were not const correct. Little things like classes like trect, tpoint, had just little getters here and there that were just not marked correctly const, and so it was good. I sent an email to the person saying, hey, here's a few cases where we're not handling this correctly, but by the way, thank you. It helped me spot lots of cases where our code was incorrect. And indeed, the audit pointed out several cases where we should have marked methods as const methods. So this is just something that's not quite C, more C++-ish if you want. So what I'll do is, like I said, I'll go a little bit under the list here. The list is very arbitrary the way it's how it's organized. The one thing that might be a little more familiar to Delphi users are the ones that are under the heading Embarcadero, because these are similar to audits that exist in Delphi. What we call internally here Sapient audits. Sapient is just the name of the original library where those audits were written a long time ago. So the one that I just saw you there was AMMC, which is, I don't know if I can highlight just that one. Yeah, method can be made const. That would be C++. There's also parameters can be made const. And several others like calling virtual functions from constructors or destructors. And the audit is actually is smart to understand our extensions also. Like, for example, it's not a good idea to call virtual functions from either constructors or destructors unless you're dealing with the Delphi style class, in which case Delphi does it a lot. It's because the way that vtables are initialized or set up during the construction phase and destruction phase of an object is different for Delphi style class than it is for a non-Delphi style class, a regular C++ class. So the audit knows that difference. Let's see, comparing float values, that's not C++ specific, but redefining an inherited non-virtual function is C++. So there are quite a few C++ audits, but the majority of them, the majority of the audits that you will find under let's say call, divide by zero, null dereference, stack address escape that I showed you, undefined binary operators, VLA size, all of these deal pretty much with C code if you want, which they're applicable to C++, but they're not very, very specific to C++. So, okay. So I hope that this has kind of given you an idea of how you deal with, or how do you run C++ audits. Let's go back to here. I'll touch on a few other things. What's missing or what's coming? This was the very, very first release of this tool. And we don't even have a command line tool version. I mean, we do have something in-house. It's used strictly for testing, so it's not something that we shipped. So we'd like to put together a command line tool. We'd like to have better report generation, maybe XML format or HTML or whatever format is something that's more structured, something that can be automated and used to publish reports. Have more audits, C++ focused ones. It's very common in the C++ world, at least, to have audits or checks or whatever you want to call them based on effective C++ from Scott Myers. So we might do a little bit of that. The item that I mentioned early on is there are two front ends, meaning your code is compiled by one compiler, but your code is being audited by different compilers. So there are cases where the two don't agree. And in general, we are trying to bridge the difference, but there are still cases. You can easily run into code that will compile, but will not audit properly. I should have pointed that out. When you write code that doesn't audit, meaning the code can't even be compiled, which means it can't be audited because there were errors in the code as far as the compiler is concerned. Those errors will actually show up in the audit view, so at least you will see them and you know that for whatever reason the code that you have is not being handled by the audit front end. Something else I would like to look at is metrics. It's not clear to us whether there is a big demand for metrics with the C++ world. It's highly used in some fields. It seems like Java and C# have a lot of metrics, or at least demands for metrics. It's not clear, so that's something we probably would like to get feedback on. Like cyclomatic complexity, lines of code, and just that kind of data, which is just basically analyzing your code and reporting any statistical information about it. And also, tied in with the metrics, I'd like to get feedback on the metrics, but in general, we'd like to get feedback also about where should this go? Like, what are the kind of things that people want to do with to audit code? Are there other areas that we should look at? Should we expose more information or less? There's also some things that I didn't mention here. Is the UI is also very rudimentary at this point. Would like to have better navigation and just better UI experience in general. So that's pretty much all I have as far as C++ audits is concerned. I will. I have my email here, and I would love to hear from people who are either using it, or even if you're not, but you're interested in the subject in that field, to let us know. Feel free to email me or anybody on the team, or go to the news groups. You can post to the forums also. I try to monitor the forums on a regular basis. And give us your feedback. And again, thank you very much for attending this session. My name is Bruno Babé, and I will see you online. Bye-bye.